Thanks, everybody. My talk is mathematical modeling of error propagation in the classroom, inauguration of new path, presented by Professor Elharrar Noureddine from Higher Institute of Nursing Professional and Health Technique Space, Safi, Marrakech, Morocco. My plan of talk is first, introduction to the SR model is relevant and valid of supporting error management in the classroom. Thirdly, mathematical modeling of error propagation in the classroom. In the final, interactive exploration of classroom error propagation scenarios, a digital application for analysis and pedagogical intervention. We start with the introduction. Error management in the classroom poses a major challenge for teachers as learning errors can hinder students' progress, affect their confidence, and compromise their understanding of key concepts. Like Astofli, in this article, we propose an innovative approach to address this challenge using the SR model, subtle, affected, recovered. Model originally developed for epidemiology by Krenak and McKendrick, and by adapting this model to the classroom setting, we examine how it can help understand the spirit of error among students, identify risk factors, preventive intervention, and correction strategies like Shavlard. We also analyze the coherence of this approach with Astoplis theoretical framework, which emphasizes considering students' mental representation and adapting pedagogical intervention. By integrating the SR model into pedagogical practice, teachers can enhance their ability to analyze, prevent, and correct learning errors while fostering a positive and reflective learning environment for students like Piaget and Halder. This approach provides an innovative conceptual framework that can help teachers effectively manage learning errors in the classroom, drawing on a deep understanding of error dynamics and intervention tailored to individual students' needs, like Wagner. The SR model divides the population of students into three compartments. The compartment of susceptible who are prone to making errors, the affected who have made errors and need correction, and the recovered who have corrected their errors and gained a correct understanding. This approach allows teachers to conceptualize error as a dynamic phenomenon and to plan pedagogical intervention tailored to each stage of the process. We pass to SR model is relevant and valid for supporting error management. The SR model is commonly used to study the spread of infection disease within a population, although this model was initially developed in the field of epidemiology. It can also be applied to other domains, including education, particularly to support error management in the classroom. Here are some reasons why the SR model is relevant and valid in this regard. Analogy, analogy between error and infection in the SR model, individuals go through different states based on their interaction with the disease. Similarly, students go through different learning states, including correct understanding, error, and correction. By using the SR model, teacher can conceptualize error as infection that spread in the classroom and affect the learning process. Understanding error propagation, the SER model provides a conceptual framework for understanding how errors spread in a classroom, similar to how the model describes how an infected disease can spread from one person to another. It can also illustrate how an error made by one student can influence others around them, especially during group activities or class discussion. identification of risk in the protective factors, just like the SR model identifies factors influencing the spread of a disease. It can help teacher identify factors contributing to error propagation in the classroom. This may include factors such as conceptual confusion, gaps in prior understanding, and common misunderstanding. Similarly, the model can highlight strategies that can act as support and reinforcement to protect students against error, such as concepts, clarification, and corrective feedback. Planning pedagogical intervention by understanding the dynamics of error propagation through the SR model, teacher can better plan their pedagogical intervention. They can develop strategies to prevent error propagation, correct existing errors, and reinforce correct understanding among students. In summary, the SR model is relevant and valid for supporting error management in the classroom, as it provides a conceptual framework for understanding and addressing error propagation in a learning environment. By using this model, teachers can identify factors influencing error propagation, plan effective intervention, and promote more effective and accurate learning for all students. Introducing the SR model as an analogy for understanding in the management learning error in the classroom is an interrogating in the potential effective approach. Here's how this analogy could be utilized. One compartment of the SR model is susceptible students who are prone to making errors or who require learning. Affected E, students who have made errors and require correction or relearning. R, recovered students who have corrected their errors and gained correct understanding. Error propagation. The initial error can be considered as the starting point of infection in the classroom. When a student makes an error, it can affect other students if they are not properly informed or, or do not understand the concept. Two, intervention to control error. Pedagogical intervention can be linked to control measures such as vaccination or quarantine. For example, immediate error correction can help immunize other students against error propagation. Classroom discussion, review activities, and tutorials can be seen as measures aimed at reducing error propagation by helping students understand concepts correctly. The SR model offers a promising approach to advance theoretically and practically and knowledge and error management in the classroom. Here is how it achieves this goal. One, solid theoretically framework. The SR model provides a robust theoretically framework based and well-established mathematical and epidemiological principle. By adapting this model to classroom error, teachers can benefit from a structured conceptually framework to understand the dynamics of error propagation and design appropriate intervention. Two, understanding error propagation mechanism. By using the SR model, teacher can develop a better understanding of the mechanism of error propagation in the classroom. This includes identifying factors that contribute to error transmission among students, as well as strategies that can be used to limit this propagation. Third, development of preventive and corrective strategies. The SR model enables teachers to design effective preventive and corrective strategies to manage errors in the classroom. For example, they can implement preventive intervention such as concepts, clarification, and immediate feedback to limit error propagation. Similarly, they can design targeted corrective intervention to help students correct their errors and reinforce their understanding. For evaluation of intervention effectiveness by using the SR model, teachers can evaluate the effectiveness of their intervention for managing errors in the classroom. This can be achieved by observing changes in the frequency and severity of errors over time, as well as students' progress in error correction and acquisition of new skills. Five, integration of empirical data. The SR model can be used as a framework to integrate empirical data on error management in the classroom. Teachers can collect data on student errors, implemented intervention and learning outcomes to assess the effectiveness of their approach and identify potential areas of improvement. We pass to mathematical modeling of errors propagation in the classroom. To model the propagation of error in the classroom, we can adapt the SR model used in epidemiology. In this model, we can consider three compartments of the student population. We can see the three compartments is E, R, by coefficient beta and gamma. S, susceptible, they are students who are susceptible to make an error. Infected A, these are students who have made an error and can transmit it to others. Are recovered, these are students who have corrected their error and can no longer transmit it. The differential equation describing the dynamics of this model are as following. We have these three equations. Depend the S and E and R by coefficient beta and gamma. The change in the number of students susceptible to errors S with respect to time t is given by this equation. To change in the number of students affected by the error E with respect to the time t is given by this equation. To change in the number of students recovered R with respect to time t is given by this equation. These differential equations describe how the number of students in each compartment of the SR model changes over time based on the error transmission and recovery rates. This model allows for modeling the dynamics of error propagation in the classroom, taking into account interaction between students and error correction process by adjusting the value of beta and gamma and identifying specific risk factors. Teacher can design intervention to reduce error propagation and promote student recovery. The curve of the SR model for error propagation in the classroom can be graphically presented over time. The curve will show the evolution of compartment S, E, and R over time. Initially, the S compartment will be high as most students are susceptible to making errors. Then the E compartment will increase as errors are made and transmitted to other students. Finally, the R compartment will increase as errors are corrected by students. The curve will eventually reach an equilibrium where the number of students who have made an error decreases and the number of students who have corrected their error increases. The interpretation of the curve will depend on the values of the parameters beta and gamma. A higher beta indicates faster transmission of the error, which could lead to a faster increase in the I compartment and a slower increase in the R compartment. A higher gamma indicates faster error correction, which could lead to a faster decrease in the A compartment and a faster increase in the R compartment. By understanding this parameter, teachers can adjust their strategies to effectively manage error in the classroom. Here is, here is a graphical representation of the curve for error propagation in the classroom, assuming they are initially 15 students in the class with 45 susceptible students and 5 infected students and 0 recovered students. We consider for different levels of learning, we will use the differential equation of the SR model and to provide initial condition. We will also use given values of beta and gamma for each learning scenario. For we have four scenarios. Scenario one, learning level one, low error transmission and low error correction. We take beta equals 0.03 and gamma equals 0.1. Scenario two, learning level two, low error transmission and high error correction. We take beta equals 0.01 and the gamma equals 0.1. For scenario three, learning level three, higher error transmission and low error correction. Beta equal 0.205, gamma equals 0.3. Scenario four, learning level four, high error transmission and high error correction with beta equals 0.03 and gamma equal 0.5. We will solve the differential equation for each scenario and plot the curves of ST, ET, and RT to visualize error propagation in the classroom. Let's now see the graphical results for each scenario. We have four figures. Every figure represents a scenario with values of beta and gamma, and we pass to global interpretation of the curves. To interpret these curves, we examine how the value of beta and gamma influence the propagation and correction of error in the classroom. A lower beta means slower transmission of error, while a higher gamma means faster correction of error. We can observe how these parameters affect the dynamics of error propagation and correction over time. Curve and interpretation in a class of 15 students. Initially, the number of affected students, those who have made an error, increases rapidly while the number of susceptible students decreases. Over time, some affected students correct their errors and become recovered, leading to a decrease in the number of affected students. Eventually, the number of recovered students continues to increase until the majority of students have corrected their errors, while the number of susceptible students decreases to a relatively low level. The curve eventually reaches a stable state where the number of affected students becomes negligible and the majority of students are recovered. We pass to separate interpretation of the curve. In scenario one, with low transmission and low error correction, the number of affected students increases gradually but remains over low, while the number of recovered students increases slowly. In scenario two, with low transmission but high correction, the number of affected students decreases rapidly and the number of recovered students increases rapidly, showing a swift response to error correction. In scenario three, with high transmission but low correction, the number of affected students increases rapidly and the number of recovered students increases more slowly, indicating rapid error propagation despite less effective correction. In scenario four, with high transmission and high error correction, the number of affected students quickly reaches a high level, and although the correction is also high, the number of recovered students remains relatively low, showing rapid propagation and less effective error correction. These results highlight the importance of effective error management in the classroom, demonstrating how different transmission and correction strategies can affect the propagation and the resolution of learning errors. We pass to the part of comparison of the four learning scenarios. Comparing the four scenarios of error propagation in the classroom, several trends and significant differences emerge. One, low transmission and correction scenario one, the number of affected students increases gradually but remains relatively low. The number of recovered students increase slowly. Error propagation is limited due to low transmission and low correction. 2. Low transmission but high correction. Scenario 2. The number of affected students decreases rapidly. The number of recovered students increases rapidly. Effective error correction quickly reduce their propagation, promoting rapid resolution. 3. High transmission but low correction. Scenario 3. The number of affected students increases rapidly. The number of recovered students increases more slowly. Despite high transmission, effective error correction leads to rapid propagation and slower resolution. For high transmission correction scenario 4, the number of infected students quickly reaches a high level. The number of recovered students remains relatively low despite high correction. High transmission and error lead to rapid error propagation even with sustained correction. In summary, effective error correction scenario 2 and 4 appears to play a crucial role in limiting error propagation, while high transmission scenario 3 and 4 can result in a rapid propagation even with sustained correction. These results underscore the importance of proactive error management in the classroom to foster an optimal learning environment. We pass to interactive exploration of classroom error propagation. To further illustrate the four scenario of error transmission in the classroom, we could consider a digital application that simulates the learning process of students in an interactive environment. This application could allow users to modify parameters such as the error transmission rate, beta, and correction rate, gamma, to observe the impact in error propagation over time. Here are some examples of possible interaction with the application. One, parameter adjustment. Users can adjust the value of beta and gamma to experiment with different error transmission scenarios, choosing low, medium, or high levels for each parameter. 2. Visualization of curve. The application displays error propagation curves for each scenario, allowing users to visualize, compare the effect of different levels of transmission and correction. 3. Result analysis. Users can analyze the results to understand how variation in parameters influence error propagation in the classroom, highlighting moments when errors peak and when they decrease. 4. Exploration of intervention strategies. The application could also include suggestions for intervention strategies based on the observed results, allowing users to explore how specific action can help reduce error transmission. By providing an interactive platform to experiment with concept of error transmission in the classroom, this digital application could help teacher better understand by underlying mechanism and develop effective strategies for managing error in their own educational context. In addition to, to the digital application allowing exploration of error propagation scenarios in the classroom, it could be useful to include the following features. 1. Parameter customization enable users to set specific value for the parameters beta and gamma based on the characteristic of their own teaching environments, enable them to better tailor simulation to their particular context. 2. Real-time feedback integrates a real-time feedback mechanism that provides information on the evolution of error propagation during the
Sorry,
simulation.
just to sorry interrupt you there, just to let you know we have 5 minutes left, so we might consider wrapping up shortly. Thank you.
Allowing users to adjust intervention strategies based on the observed result. And 3, pedagogical support provide additional pedagogical research such as article videos, or case studies to help users develop their understanding for error transmission concept and best practice for results sharing over the ability to save and share simulation results with other teacher or education professional. And we pass to integration of the tool into teacher training. To maximize the impact of this tool, it would be beneficial to integrate it into teacher training program. By offering dedicated training session, teacher could learn to effectively use the tool to analyze class dynamics, identify friction point, and design target intervention. And we finalize by some reference in this talk. And thank you for your attention. Have you any question, please?